Hi students, so today we are going to start Math Question Bank 3. So I'm going to discuss a set of 10 questions and then I'm going to solve them. Now these questions are typical questions which you may be asked in interview settings, for example for master's, PhD, even bachelor's level. And sometime you may be asked these questions in interviews for jobs in science, technology and engineering domain. Also, you can be asked these questions in any exams and so on in mathematics. So let's begin. I'm Dr. Ganguly. So the first question tells you to find x by y minus y by x, and you have been given the fact that x squared by y squared plus y squared by x squared equals 38. Question number 2 asks you to solve a simple differential equation. You do not actually need to know anything about differential equations to solve this. You can do this if you know calculus and integration. Question number 3 asks you to prove this particular inequality, that is 222 raised to the power 333 is greater than 333 to the power 222. So this is something we need to show. The fourth question involves a definite integral, and this definite integral is set to 0 and you are asked to find the value of k. So this is testing your knowledge of basic definite integration. Question 5 gives you three planes and it's told that these planes intersect at a certain point and you have to find the value of k, which is given here. So this of course is a three-dimensional problem in coordinate geometry. You have x, y, z or x, y, z depending on what you like more. The question number 6 asks you to find this indefinite integral, which is root of 25 minus x squared dx. Question number 7 tells you that there is a point on the xy plane which is equidistant to these points, and three points are given here, a, b, c. Again a three-dimensional problem in coordinate geometry. Question number 8 asks you that is the following function continuous everywhere, and the function is given as follows, that for x is less than 0 it is 2x minus 1, and for x is greater than equal to 0 it is 2x plus 1. Question number 9 gives you a particular matrix. So this is the A matrix, 1 tan x minus tan x 1. It's a 2 by 2 matrix and you are asked to find the inverse of this matrix. And finally, question number 10 tells you that there is a set of vectors. These are A, B, and C. And you have to show these three vectors form the side of a right angle triangle. Remember that I, J, K are the unit vectors in the X, Y, and Z directions. So we are going to now solve these problems. Of course, if you are somebody who is thinking about taking the quiz, you can take it and then you can look at these particular answers. So let's start with answer number 1. Again, I'm going to put the question out here in red. I'm going to put the solution in blue and I'm going to give the final answer in green. So we are going to use this color coding here. So now in this problem you are given this particular fact that x squared by y squared plus y squared by x squared equals 38, and you have to find this. Now the main thing about this thinking process is that you should be able to understand that squaring this is going to help you, because squaring this is going to give you terms involving x squared by y squared and y squared by x squared, and that's going to bring you nearer to the solution. So what we can do of course is that we can look at this equation, because this is something which we already know, and we can express this in a form such that x by y minus y by x comes in. So if you recall the basic formula that a plus b square is a square plus 2ab plus b square, and the corollary is that a minus b square is a square plus b square minus 2ab. So using that particular formula we can write this here. If we put a negative 2 on both sides, then we can see that this expression I get on the left hand side is nothing but x by y minus y by x squared, because remember this is going to get squared, that's here, this is going to get squared, that's here, and the term here is basically 2 into x by y into y by x with the negative sign here because there's a negative sign here. So essentially I'm using the fact that a minus b square is a square plus b square minus 2ab. Now if I can make this particular transformation, then the problem becomes extremely simple. I can take the square root on both sides, and so 36 becomes plus or minus 6. So I can immediately write that x by y minus y by x is plus minus 6. So this is a nice warm-up problem. So now that we have slightly warmed up the brain, let us do number 2 problem, and this was the differential equation here. Now here of course the main thing you can see is that you can take e to the power negative y outside this in terms of putting a bracket here and then have a function involving only x. So we do that here. We can write dy by dx is e to the power minus y and ex plus x squared. So this is a critical step, and this makes the differential equation such that you can separate it into two parts. The left hand side is something which is dependent on only y, and the right hand side is something which is dependent on only x. And once I do that, I can very easily integrate this function, and the integral simply becomes ey for ey. Now this is something very interesting. The exponential function is probably the nicest function when it comes to differentiation and integration, which you can see here. So we can write this as ey is ex plus x cubed by 3 plus c. So remember, x square is going to get integrated as x square by 3, and I can take the log on both sides and I immediately get the solution. Y is log of ex plus x square by 3 plus c. Now remember at all times to put this c here as a constant whenever you are doing any indefinite integral, because in many physical problems the things which are manifested by the physics such as boundary conditions, initial conditions, they all come in through the constant here. So sometime if you do not put the constant, there are professors and teachers out there who may give you zero or partial credit for this particular problem. Let's come to question number 3 and try to do it. And here of course if you take a look at this particular inequality, you will clearly see that there is a certain factor which is coming here, and that is the number 111. And so if I can figure this out, which is not very difficult, I can write this immediately in this form, that this is 111 into 2 and this side is 111 into 3. I can then expand this out here. Now this thing, if I look at it further, I can make some more simplification. So I can write this 2 to the power 333 as 2 cubed to the power 111. I can write 111 to the power 222 as the same thing, and I can write 3 to the power 222 as 3 square to the power 111. Now what I'm trying to do here is I'm going to get the different terms such that the power is going to be 111 everywhere. So we are going to be able to do that because this is one of those problems which has been created with this trick in mind, and what it's trying to figure out is that can you figure out whatever trickery has been used to create the problem. So once I do this here, what I can do is I can write 2 cube as 8, I can write 3 square as 9, and I can immediately see that there is going to be some cancellation which is going to be possible here. So if I were to divide both sides of this particular inequality by 111 to the power 222, then I would get only 111 to the power 111 remaining on the left hand side. So now once I obtain this, I can of course combine these two because the powers are same. So I get 888 to the power 111 is greater than 9 to the power 111. Now comparing these two, I obviously understand that since the powers are exactly the same, whatever is inside is going to have a huge impact, and inside here is a much larger value. So since 888 is greater than 9, this particular term on the left hand side is going to be greater than the right hand side. In fact, it's going to be much greater than the right hand side. So certainly as far as this inequality in red is concerned, it's true, and we have shown it in this particular way. So we have proved this fact which was stated here. Let's come to question number 4 and try to solve it. So question number 4 essentially had this definite integral, and this definite integral was set to 0, and you are asked to find the value of k which makes this possible. Now this kind of problems often show up in different physics problems and mathematical physics problems, and let's try to do it. So if you know about the concept of definite integration, you know that what you have to do is you have to integrate this function, and then you write this 1 and 0 here. These are the two bounds of the definite integral, and so that's what we do here. 3x squared becomes 3x cubed by 3, 4x becomes 4x squared by 2, and k becomes kx here. Now I simplify this. There is some cancellation of 3, there is some cancellation between 4 and 2, so I get x cubed plus 2x squared plus kx. 0 to 1 equal to 0. Now what this nomenclature here means, this 0 to 1, is that I have to calculate this function at 1 and then I have to subtract from it the value of the function at 0. So I do that here. So I take this function, I put 1 throughout the places where x was there. So I substitute x is equal to 1 in this function here, and then I subtract this from the same function value at x is equal to 0. So here I have put x is 0 in this function here. Just to show you the details, it's quite clear of course that this is simply going to be 0, but there may be problems where this is not going to be 0, so you always need to calculate the value of the function at both these particular bounds. Now let's look at the left hand side. This is going to be simply 1, 1 cube is 1, 2 into 1 is 2, and k comes here, so I can straight away say that k is equal to minus 3, or k is equal to negative 3. That's the answer here. So I should have put it in green, but I think I forgot that. Let's come to question number 5. And here you are given equations of three planes. Remember, in 3D coordinate geometry, if you have an equation like that, it's going to represent a plane. In 2D geometry, you would have x plus y equals something that would be a straight line. But when you add the z or the z coordinate, it becomes the plane equation. Now, the fact is stated that these all intersect at a given point. So that would mean that this particular point would satisfy all these three equations, because these planes have to pass through these equations if they are going to intersect at this point. So let's check this out. Let's take these three equations and simply substitute x is equal to 1, y is equal to 1, and z equals to 1. So I substitute this here. I get these three equations. Now, the first two equations simply verify the fact. So here you can see 1 plus 1 plus 3 equals 5. That is true, because 3 plus 1 is 5. Here 2 plus 2 is 4, minus 1 is 3. So this is also true. Now we turn to the third equation. So you have 4 into 1 plus 1 minus k equal to 2, or we can say here 5 minus k equals to 2, or we get k equals 3. So this is the solution of this particular equation here. So this problem is quite simple. It does test various concepts here. Now, of course, the problems I'm giving you are problems which can be easily done in a blackboard or a whiteboard, or even if you are somebody who is doing this problem in an online interview like in Zoom or Team, it's very easy to do that. Now let's come to a somewhat more cumbersome question, and this is integral of root 25 minus x squared dx. Now, when you look at integrals of this type, you generally know that some trigonometric substitution is involved here, because whenever you see something like 1 minus x squared, it's going to greatly benefit if you put a sine or cosine substitution. So that's going to essentially use the fact that sine square x plus cos square x equals to 1. That's a very well known equation which is present. So what we do is we substitute x is 5 sine t. That is a different intermediate variable, and so I immediately get dx is 5 cos t dt. Remember, derivative of sine t is cos t. Now I make that substitution within this integral here, so I get this value here. Now the reason for selecting this 5 here is that the 25 value would come here, and so you could take this outside. It would become 5, and so 1 minus sine squared t would become a cos t. That's the whole logic of making this kind of substitution. So in problems like these, you have to think a couple of steps ahead so that you can make these substitutions. So once we do that, we can take a 5 outside here, we can take another 5 here, we get a 25 here, and we get integral cos squared t dt. Now here I have to use a relationship. These relationships are very important in definite integration or in integration in general. The relationships which convert the square of things such as cosine and sine into the cos 2 or the sine 2 x type of situations. So cos square t is 1 plus cos 2t by 2. So if I know that, I immediately can integrate this function here. The first function would simply give me 25 by 2t. The second function would give me plus 25 by 2 sine 2t by t, and remember the very important constant c. Now I need to express this back in x, because remember the integral was posed in x and the solution should also be expressed in terms of x. That's not going to be so easy with 2t here. So what I'm going to do is I'm going to break it out. So I'm going to break it out by using one more formula which is very important, that is sine 2t is 2 sine t cos t, and once I do that, I substitute for t here. So t is going to be simply inverse sine x by 5. So that's the first part here. The second part will become 25 by 2 into x by 5. X by 5 simply comes from the sine t value here, and then you'll get cos of sine of inverse x by 5 plus c. Now here you will have to do one more substitution, and that substitution is required because we have to express this sine in terms of cos. So we do that here. We use the formula that cos of x is root of 1 minus sine square x. So we use that formula here, we get something like this, and then we use the fact that we essentially have a term here which is a sine of a inverse sine and one more such term. So two such terms are there. So this expression simply becomes x by 5 square. And then after doing some more simplifications, we get this equation in green here. So there is one term here, 25 by 2 sine inverse x by 5, and the other term is x by 2 into this equation here. So this kind of integral is quite easy to do provided you remember the trigonometric substitutions, and these are often used to actually test two things in one shot. So you can test the student for not only his knowledge about integration but also about his or her knowledge about trigonometry. So you can essentially kill two birds with one stone with these kind of problems. Now let's look at question number 7. So in this question, what happened is that we are told that there is a point on the xy plane and it is equidistant to 3 points A, B, and C. So essentially the point being on the xy plane means that the z or z coordinate is 0. So the point is going to be P, X, Y, 0. So that's the point. Now this point also has the same distance to these 3 points, which means PA equals PB equals PC, and also it would immediately mean that PA square equals PB square is PC square. Now I know of course that I can calculate the distance between any 2 points from coordinate geometry. So the formula of that is simply I have to take these coordinates, I have to take these coordinate and I have to find the distance between them. So let's find PA square. So that would be taking 203 and finding the distance from xy0. So that would give me here 203 and xy0. So we have to take each of these coordinates and we have to subtract the different coordinate from it. And now right hand side would be PB square. So B is again 004. So you see 004 here, and P is XY0. So you see XY0 here. Now let's simplify both sides. 2 minus x square gives me 4 minus 4x plus x square. This gives me y square. This gives me 9. And here I get x square plus y square plus 16. I do some cancellations as far as x square and y square are concerned. So I get immediately 9 plus 4 is 13 minus 4x equals 16, which gives me x is negative 3 by 4. Now the second part of the problem can be solved by realizing that PB equals to PC, or the squares are also equal. So let's look at PB here. PB is the same as what we calculated here. So we write that out here. And PC will come by looking at C, that is 0, 1, 0, 0, 1, 0, and subtracting from X, Y, 0. That's the coordinate of P. So on the left hand side, I simply get X square plus Y square plus 16 as I got here. On the right hand side, I'm going to get X square term here. 1 minus Y square is going to give me 1 minus 2Y plus Y square. And this term is simply going to give me 0. So I am going to simplify this. Again, there is a cancellation on X square, Y square, and I'm going to get 16 on this side. This is equal to 1 minus 2Y. So Y is going to be minus 15 by 2. So the point has coordinates minus 3 by 4, minus 15 by 2, and of course the Z or Z coordinate is 0 because this lies in the XY plane. Now, finding the distance between any 2 points is a very fundamental concept in coordinate geometry, whether in 2 or 3 dimensions. So essentially this problem is testing that you know some of these basic formulas. Now let's come to question number 8 and try to solve it. So we were given this function here which has different functions essentially at x is less than 0 and at x is greater than equal to 0, and we are told that is this function continuous at all places. Now of course you know the problem of this function is going to happen at x is equal to 0. So let's look at the extreme cases. When x is less than 0, this function is simply 2x minus 1, which is a line simple polynomial. It's going to be continuous on x is less than 0. Now if x is greater than 0, the function is simply 2x plus 1. Once again, this is a simple line, so it's continuous on x is greater than 0. Now to find what happens at x is equal to 0, we should take the limit from two sides. So if we take the limit from the left hand side or the negative side of the number line, then what happens is that limit x tends to 0 from the negative side. That's going to be limit x tends to 0 from the negative side, and we have to take this value 2x minus 1. That's going to give me minus 1 here. Now the second case, x is equal to 0, limit x tends to 0 from the positive side, and this is going to give me this thing value here. So from the positive side I have 2x plus 1, and so when x tends to 0 from positive side, again I get 1 here. So these two are different, and therefore this function is not continuous at x is equal to 0, but it's continuous everywhere else. So that's the answer of question number 8. Now let's come to question number 9, and here you have been given a matrix and you have been asked to find the inverse of a matrix. Now this is a very important manipulation or step which is required throughout the mathematical sciences. So this is something you need to know in your memory. So if you have been ever given a 2 by 2 matrix of the form A, B, C, D, then as far as the inverse is concerned, it is 1 divided by determinant of A, D minus B minus C, A. So a simple way to remember this is that as far as these terms are concerned, B and C, you simply change the sign. So if these are plus, you make them negative, and these two terms A and D are concerned, you simply flip them. So essentially the A term goes here and the D term goes here. So this is something you should keep in your memory, and if you have that in your memory, you can immediately write A inverse is given by this particular value. Now once you have that, you see what we have done is, as far as this problem is concerned, since A and D are same, the ones remain same, and the only thing which happens is that the tan x terms get switched. So essentially the negative term becomes positive and so on. So here minus tan x has become tan x, and here tan x has become minus tan x. Now the determinant of A is simply going to be A into D minus B into C. So if I do that, 1 into 1 is 1 minus these two tans and a negative sign, and so I get 1 plus tan square x, which is sec square x, which you will remember is 1 by cos square x. So I get A inverse is cos square x here. So 1 by sec square x becomes cos square x, and this is 1 minus tan x 1. I can bring the cos square x inside here, so I get these two cos square x term. Tan x is nothing but sin x by cos x, so sin x by cos x multiplied by cos square x simply gives me sin x into cos x, which gives me this as the inverse of this matrix. So that was another straightforward problem, but it's something which tests a very basic and fundamental skill about whether you know how to invert a given matrix. Now let's come to our final problem. So we had these three vectors and we were asked that do these three vectors constitute the sides of a right angle triangle? Now one of the things we can take a look at these three vectors and we would like to know which side is biggest, for example. So if we look at these three vectors, we will clearly see that a plus b equals c. So this you can see from the values which are given here. 2 plus 1 is 3, minus 1 minus 3 is minus 4, and 1 minus 5 is minus 4. So I can write a plus b is c. So that's something which you will clearly have in the case where the resultant of adding these two factors is the third vector. So that is certainly a good sign. Now we essentially know that C is the larger component, and so A and B must be this component, assuming this is a right angle triangle. Now if this is a right angle triangle, then A dot B should be 0. So let's try to calculate A dot B. So A is here and B is here. To take the dot product or the scalar product, I take 2 into 1, minus 1 into minus 3, 1 into minus 5, and so I get 2 plus 3 minus 5, which gives me 0. So the dot product being 0 means that A and B are perpendicular, so this is certainly a right angle here. Now if I am further interested in proving one more point, then what I can do is I can calculate the magnitude of these three vectors, and this should essentially satisfy Pythagoras theorem. So let's calculate the norm of A. So that would be 2 square plus minus 1 square plus 1 square. So these are the values of the coefficient of I, j, k squared. So you get here uh, 4, 1, 1, that is 6. B square would be simply 1 square minus 3 square minus 5 square, so that's 35. And C square is 3 square minus 4 square minus 4 square. Again, these coefficients are being squared, that is 41. And so I immediately see that C square is A square plus B square, because 35 plus 6 equals 41. So I clearly see that this has all the manifestations or representations of a right angle triangle here. So these were some questions I had for you today. Again, like I mentioned, if you are somebody who is a professor or somebody who is a teacher looking for questions, maybe for some examination, or you are a student preparing for any board exam or some competitive exam, then these questions are going to be useful for you. Now, many a time people are able to answer questions like this very simply when they do their classwork and homework. But what happens in examinations and the different interview settings is that you are suddenly asked these questions out of thin air, and at that point what is required is that you have internalized all this information and this has been stored in your memory banks. In that case, you can very easily do these questions. So this set of questions I am creating is actually like a general knowledge of mathematics which engineering science students should have. So you should certainly know this much mathematics if you are going to be somebody who is going to survive in the STEM world. So I'll stop this video now. If you have any issues with any of the solutions, please let me know. If there are any mistakes, or even if there are no mistakes also, that's nice if you can tell that those mistakes are not there. If you have any special problems which you would like me to look at, please also leave those in the comment section, and I will see you in a new video sometime soon. See you then.